Okay, everyone, welcome back. This is our statistics class notes, section 7.4. We're just about a fourth of the way down the page, page 110, looking at example 139. So I'm going to right now talk to you about how we create confidence intervals using StatCrunch. In this exercise, we're going to create a confidence interval using StatCrunch and investigate what happens to a confidence interval and the margin of error when the level of confidence increases and all other summary statistics stay the same. Okay, so according to pewresearch.org, a 2014 survey found that 32.1% of adults aged 18 to 34 were living with their parents. Suppose that this was based on a random sample of 1,200 adults in this age group. Excuse me, sorry for the yawn. Okay. First, we need to check that the conditions of the central limit theorem apply. One, well, we're going to assume again that there's a random independent sample. Two, we need to know if there was enough successes and failures. Can we expect enough successes and failures, or were there enough successes and failures in our sample? In this case, we had 32.1% of our sample say that the adults that responded were 18 to 34 living with their parents. So that 32.1% of our sample size of 1,200 is actually 385.2. So round that to 385 people. That's certainly greater than 10. So the amount of people that were not living with their parents in our sample were 1,200 times 1 minus 0.321, which is around 815 people, also certainly greater than 10. So the sample size is large, and it's also reasonable to assume that the population of all adults aged 18 to 34 is bigger than 10 times our sample size of 1,200, which is 12,000. So there's 10 times our sample size. Our population needs to be bigger than that, and that's certainly a safe assumption. So the central limit theorem applies. Now we're going to go ahead and use StatCrunch and find confidence intervals. Find confidence intervals, but using different confidence levels. 80%, then 90%, then 95%, then 99%. Okay, we're going to record our stuff on the next page, and I'll show you that, but let me run through those real quick for you. So let's go over to StatCrunch. Okay, so where you do this is you go to Stat, and we are doing proportion statistics right now, and we're doing one sample. And we don't have the data. We don't have, like, if when you were given all your data for your projects, you had all the different data in different columns. We don't have that. We just have a summary of the data. We know the number of successes and the number of failures and what the sample size was. So we're just going to click with summary. Okay, now the number of successes that we had, remember we computed that to see if our sample size was large enough. So it was 32.1% out of our sample size of 1,200. It came out to be 385. So that's our number of successes, the number of people that still live with their parents who are age 18 to 34. The number of observations is actually just the sample size, so that's 1,200. And then we are doing a confidence interval. So we need to click the confidence interval. And we're going to do an 80% first. So I'm going to do an 80% confidence interval, which means I'm going to change this 0.895 to 0.80. And that's all we need to do. So we just need to put in the number of successes, number of observations, which is sample size, and click the confidence level, which is 0.8 for 80%. Hit compute. The results pop up here. Make it a little bigger so you can see it better. Oh, it doesn't work to make it bigger. Okay. So what it tells you is it actually finds the sample proportion, which we know was 32.1%. So remember we rounded that 385.2 down to 385, so that's why it's a slightly different number, but there's not much we can do because we have to put in the number of successes. Came up with a standard error. We didn't have to compute the standard error estimate. This is just an estimate because it doesn't know P either, so it's using our sample proportion. And it gives us the lower limit and the upper limit. So we record that in the table that's on the next page. Now if I want to find a different confidence level, all I got to do is go to Edit, change this to 90 for 90%. Hit compute. Come over here and I got all the same information. It's now a 90% confidence interval, and there's my lower limit and upper limit. Now notice that my lower limit here and my upper limit, the lower limit is lower than it was for the 80% confidence interval, and the upper limit's higher than it was for the 80% confidence interval. So my confidence interval is wider when I want it to be more confident, and that makes sense because we need to include more values in our interval to be more confident that we actually have captured the true population proportion in it. So I won't go through all of them in this video, but then you could do the 95 and the 99 the same way by just editing that confidence level. And you can see them on the next page. We've put them all into the table, and hopefully you've done that. You've run through these to show yourself what the lower limit and upper limit is. And then I also computed the width of the interval as we kept going up in confidence. So with more confidence, the interval becomes wider and wider. That's the key point of this example here. The confidence interval got wider as the level of confidence increased. Is it plausible to conclude that the true percentage of adults in this age group living with parents is 38%? No, 38% or 0.38 as a proportion is way outside every confidence interval here, right? The widest confidence interval is the widest confidence interval is 99%, right? The higher the confidence, the wider it gets, because we want to see if we can capture more values to see if the true population proportion is in there. And even the wide one doesn't put 38% in there. The highest value it goes up to is 35.55%. So again, our key point, as the confidence level increases, the width of the confidence interval also increases. Higher confidence, larger width of the interval.